The temperature of the hot air is determined by the opening of the fuel gas valve and the opening of the fresh air damper. Based on the process understanding from previous videos, this video proposes alternate control logic for these two final control elements. Which of the final control elements is most appropriate for controlling the scrubber duct inlet temperature? Suppose all other control variables, that is, hot air pressure, hot air temperature, and baghouse inlet temperature, are maintained at their targets. To increase the scrubber duct inlet temperature, the heat input rate to the furnace must increase. This suggests pairing the scrubber duct inlet temperature with the fuel gas valve. The control each variable with the nearest valve philosophy suggests that this valve is too far away for effective control. The hot air damper to scrubber duct inlet affects the scrubber duct inlet temperature more rapidly, but the effect is only temporary. We should use a final control element that causes the process to do what is required without relying heavily on the other loops. For controlling the scrubber duct inlet temperature, that final control element is the fuel gas valve. The scrubber duct inlet temperature controller is configured using a simple PID block. The PV is the scrubber duct inlet temperature. The controller output is the opening of the fuel gas valve. The action is reversed. If the scrubber duct inlet temperature is increasing, then reduce the fuel gas valve opening. To avoid a furnace trip on a low firing rate, a value of 30% must be specified for the lower output limit. If configured this way, the scrubber duct inlet temperature controller could be tuned if used alone. We shall not do so, and let me explain why. As the designers envision, the hot air would be used in a constant temperature, variable volume manner. That is, the hot air temperature would be maintained at a fixed value. The heat input to the process would be determined by a variable hot air flow. What if used alone in the revised configuration? The scrubber duct inlet temperature loop adjusts the heat input. This affects the hot air temperature, but has no effect on hot air flow. As a result, the heat input is being varied by using the hot air in a constant flow variable temperature manner. Since this is very different from what the designers of the process envisioned, tuning the scrubber duct inlet temperature controller will not be undertaken at this time. This carries over to the tuning order for the final configuration. Starting with tuning, the scrubber duct inlet temperature controller is not appropriate. The hot air temperature depends on the opening of the fuel gas valve and the fresh air damper. The fuel gas valve is used to control the scrubber duct inlet temperature. Consequently, we must control the hot air temperature using the fresh air damper. One option is to configure a simple PID loop for this purpose. The performance of such a loop would be similar to that of the hot air temperature loop in the single loop configuration. Whether adjusting the opening of the fuel gas valve or adjusting the opening of the fresh air damper, the dynamics of the hot air temperature loop are largely determined by the thermal mass of the furnace. The hot air temperature loop responds slowly, regardless of the choice for the manipulated variable. With the two loops configured as proposed, the off-gas process uses the hot air in a constant temperature variable volume manner. Opening the fuel gas valve increases the heat input and the hot air temperature. The hot air temperature controller responds by opening the fresh air damper, which increases the fresh air flow so as to maintain a constant hot air temperature. At constant openings for the two hot air dampers, opening the fresh air damper increases the hot air pressure. To maintain constant hot air pressure, the openings of either or both of the hot gas dampers must increase. That is, changes in the flow through the fresh air damper must be translated to changes in the flows through the two hot gas dampers. A future video will propose a hot air pressure controller for this purpose. The next video proposes a ratio control configuration that attains constant temperature variable volume behavior without relying entirely on the hot air temperature controller.